Okay, we're going to do sequence and series part of this math rescue plan. And there's a sheet like this that gives you the whole story of sequence and series. There's a lot of stuff here. It's a good little sheet to have to go over this, but we're going to go over sequence and series information. But I'm going to do something a bit different. I'm just going to go with the absolute basic stuff and explain it sort of simply in context. So let's start here. When you're looking at formula sheet, your formula sheet, and you see Tn, that means you're looking for a specific term, like the third term, the fourth term. There's the third term, there's the second term. The 50th term would be 50 numbers along. That's what n stands for. Sn means you're adding up the terms, 2 plus 5 plus 8. You have to know that. You have to know A is the first term. N is that specific term or all the terms added up in a sum. D is a common difference. And we're going to look at that in a second. And R is for the common ratio. Well, the common difference goes with an arithmetic sequence that's going up by the same amount each time or going down. And you can always get the common difference by going T2 minus T1, 5 minus 2. And that would be a common difference of 3. D would equal 3 there. Well, and you can also get it by going T3 minus T2, 8 minus 5. That'd give you 3. You can use that relationship to make an equation to do problems that are harder, but this is it's fundamental for arithmetic sequences. Now, geometric means if I divide the two, T2 divided by T1, I get the common ratio, which is 3. So I must be multiplying by 3, 5 times 3. And T2 over T1 should equal T3 divided by T2. Well, 15 divided by 5 is 3, but 45 divided by 15, that's 3. That's called the common ratio. Now, a quadratic sequence isn't being multiplied by a number, and it doesn't go up by the same amount. But if we make this triangle, 3, 8, and 5, and we subtract to get this first difference here, we go 8 minus 5, 8 minus 3, we get 5. We got to subtract 8 minus 3, we get the first difference. The second difference is 15 minus 8. Well, then we subtract again to get what's called the second difference. And this is 2. Now this goes, if we made this triangle bigger, we'd have 2's, and the second differences go constant. Now with quadratic sequences, you memorize these three little expressions, 2a, 3a plus b, and a plus b plus c, and you put them in front of these numbers, always in front of the second difference, 2a, always in front of the first difference, 3a plus b, and the first term, a plus b plus c. And then you start with the a. 2a equals 2, divide by 2, a is 1. So you've got one of your answers you put in front of n squared to get the equation of the quadratic sequence for finding any term. Then you take that 1 and you put it back in there. 3 times 1 plus b equals 5. Well, that's 3. B must be 2. 3 plus 2 is 5. Take away 3, you get b is 2. And now we know a is 1 and b is 2. We put it back here. 1 plus 2 is 3. That part is 3 plus c. The only thing it can be is c equals 0. So there you go. You've got b is the number you put in front of n, is 0 is the number you added on. So Tn is n squared plus 2n. Okay, that's that part. Now, when you get an infinite series question like this, where you're saying it's saying for what values of k does the sum converge? What they mean is if you keep adding it and adding it and adding it, something's getting smaller and smaller and it becomes one number. Well, the answer for convergence is right on your sheet. It's that the number that you're multiplying by, if it's between 1 and minus 1, then it converges. So it converges when k is between 1 and minus 1. And that's all there is to it. Now it says determine the sum of this infinite series. Determine k if the sum of the infinite series is 9. Well, that means the s part's 9. And we go a, the first term is 3. and we're trying to figure out R or K, the thing it's getting multiplied by. So you'd get a mark for that. And then maybe one if you went 9 times 1 minus K, if you took away 9 and got minus 6, and then if you divided by minus 9, you'd get K equals 2 over 3. And then I think it's worth to know the sigma notation. Write this infinite series in sigma notation. So we're multiplying by K. So you just put your K, the thing you're multiplying by there. And you always write n minus 1 and then n equals 1 there. So the first term, if I put 1 minus 1, it makes 0. So I just get the 3. If I put the number 2 in, 2 minus 1, I get 3 times 2/3. And it works for all of it. What this means is you put in 1, then you put in 2, then you put in 3, and you keep on putting in numbers, 100, a million, you keep on going into infinity. And if you do that and you add them all up, it will converge to equal 9. One other trick that's really useful. If sometimes they just tell you that the formula for the sum of a series, maybe it's an arithmetic series, but they tell you this formula. This is the formula for finding the sum of anything, 5 terms, 10 terms. But they ask, what's the 12th term? Well, there's a trick. And all you do is take the sum of 12 and subtract the sum of 11. The difference must be the 12th term that you added. You had the sum of 11, then you added another term, and you got the sum of 12. So this is always true. The sum of whatever they're asking for minus the sum of 1 less than that. And now all we do is take 12 and put it in there, take 11 and put it in there, and subtract them. See, I did it on the calculator. You can see, and the calculator gave me the number 46. So that's your whole sequence and series in a nutshell. Okay.